Alright, what's up guys? Mr. Rushka here. Today we're going to just finish up our 1.7 notes, okay? So let me start a 25-minute timer here, right? And I'll try to lecture for 25 minutes, okay? I figured that'll give you enough time to finish the video after your quiz, hopefully. Okay, so we're just going to finish up these last 5 problems we didn't get to yesterday, okay? So starting with number 32 in the textbook, okay? So we got 32, 35, 37, 38, and 39 today, okay? So first off is number 32. The chemistry lab at the University of Hardwoods keeps 2 acid solutions on hand. One's 20% acid and the other's 35% acid, okay? All right, and the question is how much 20% acid solution and how much 35% acid solution we should use to prepare 25 liters of a 26% acid solution, okay? So coming over here to the notes, okay, so number 32, what I'm going to do here is I'm going to allow X to equal the liters of the, 20% acid solution I'm using. All right, and I'm going to let Y equal the number of liters of the, 35% acid solution I'm using, okay? All right, so there's that. Okay, now there's 2 constraints here, okay? So the total amount of liquid we end with has to be 25 liters, right? It asks us to prepare 25 liters of a 26% acid solution. So the total solution has to be 25 liters. Right? So that means the number of liters of X plus the number of liters of the Y solution I have, that has to equal a total of 25. So that's where I get my first equation for this, okay? Now our second constraint is a little more subtle, right? But we can see it, right? So we have to have 25 liters of a 26% acid solution. So the total amount of acid we actually have to have, okay? So our solution isn't all acid. Some of it's going to be water, okay? So the total amount of acid we want to have at the end is going to be 26% of 25 liters, or 0.26 times 25, okay? And that's going to equal, okay? That's the total amount of acid we want to have in our solution at the end, okay? That acid's going to come from, the 20%, so the 0.2% of the X liters of my 20% acid solution, and then the other part of my final acid at the end that I'm going to have is going to come from the Y liters of my 35, or 0.35, my 35% acid solution. So these are where my 2 equations are going to come from, okay? And then at this point, actually, the setup's all done. It's just an algebra 1 problem at this point, okay? So let's go ahead. Let's write this a little neater. So my system is X plus Y equals 25, and 0.2 X plus 0.35 Y equals, okay, 0.26 times 25. Let's plug that into the calculator real quick. All right, that's going to be 6.5, okay? Here's my system. All right here, okay? So at this point, it's an algebra 1 problem, okay? Let's try a U sub. Let's do a U sub starting from this top equation right here, okay? So subtracting X from both sides, I get Y equals 25 minus X. And I'll just go ahead and sub this in for my Y right here, okay? So we get 0.2X plus 0.35 times my Y, which is 25 minus X. We know that's going to equal 6.5, okay? Now we have one equation, one unknown, so let's solve, okay? So distribute, I get 0.35 times 25, what's that? 8.75, so I get 8.75, okay, so 0.2x plus 8.75, right, minus 0.35x, that's going to equal 6.5. Okay, let's combine my 2 like terms right here, okay? So 0.2 minus 0.35, I believe that's negative 0.15x, plus 8.75 equals 6.5. Let's subtract 8.75 from both sides. All right. We get negative 2.25, and that's all equal to my negative 0.15x, okay? Divide by negative 0.15, divide by negative 0.15. You get x equals, okay, negative 2.25 divided by negative 0.15. X equals 15, okay? X equals 15 right there, okay? And then I can just plug that right back into here, okay? So I have my x equals 15 here. I can plug this into my y equals 25 minus x, so I get y equals 25 minus 15, which equals 10, okay? Which equals 10. So x equals 15, y equals 10, okay? So I want, what was x again? It was the liters of my 20% acid solution, and then y was the liters of my 35% acid solution. So my final solution here is we want 15 liters, right? We got to interpret this in the context of the problem for our answer, okay? Since it's a story problem. So we want 15 liters of the 20% acid solution, and we want 10 liters of my 35% acid solution. And there you go. That's my solution right there, okay? So go ahead. I know I might have done that a little fast, so pause, rewind, ask Mr. Miller for help if you need to, okay? All right, so I'm going to go ahead, get rid of this so I can have room to do my number 35. Okay, so going on to number 35. Okay, so let's look at that. Oh, excuse me, let's look at that. All right, protecting an antenna. In example 3, suppose the parabolic dish has a 32-inch diameter and is 8 inches deep, and the radius of the cardboard cylinder is 8 inches. Okay, so now how tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? Okay, guys, here's how this one works, okay? So this is number 32 that I'm on, number 32 right here, okay? So we're going to have a dish that's shaped like a parabola, okay? We're going to have a dish that's shaped like a parabola. It's like a little U-shape type there. Let me make that a little better. Let me make it look more like a parabola. There we go. It looks more like a parabola, okay? So we're going to have a little parabola, okay? And we know that the top of my parabola is 32 inches across. It's going to be 32 inches across, okay? And it's 8 inches deep. So from the top of the parabola to the bottom of the parabola, that's going to be equal to 8. Okay, and what they're saying is, okay, so I'm going to let's use green, okay? What they're saying is we want to fit a cylinder in here inside my parabola with an 8-inch radius such that the top is flush with this red dotted line here. So let's draw that. So we're going to have the base of my cylinder is right. It's half of that base is going to be 8 inches long. So the entire base is going to be 16 inches long, okay? And then the top of that cylinder is going to come up to this red dotted line, cross, and then back down to the base, okay? So this is our diagram right here, okay? That's our little diagram, okay? Now, here's how I'm going to do this problem, okay? Here's how I'm going to do this problem. So we know what I'm going to do. This is very physics-esque. This problem is a lot like a physics problem. So I'm going to keep in mind, right, my base. So my base, I'm going to move this down here. My parabola is 32 inches wide. Okay, it's 32 inches wide. And it's still, how many feet deep? Or how many inches deep? It says it's 8 inches deep. 8 inches deep, okay? So here's how I do this problem. I'm going to draw, let's use pink. I'm going to draw my y-axis, or my x-axis, my horizontal axis, right through here. Okay, right through that red dotted line. I'm going to call that the x-axis. And then I'm going to split my parabola by drawing right down the middle. And I'm going to make that my y-axis, okay? So here's the origin right here, my point 0, 0, okay? It's right at the top of my parabola, okay? And right in the middle of it, okay? So let's label I'm going to start by labeling my y-intercept here, okay? My y-intercept, what is that? I start at the origin. I don't go to the left or right at all, so my x-coordinate for my x-intercept is 0, just as always, okay? Or the x-coordinate for my y-intercept is 0, just as always. What's my y-coordinate going to be? Well, I'm starting at the origin, right? My height is 8, so I'm going to go down 8 from the origin. That means my y-coordinate here is -8, okay? Now I want to label my x-intercepts, okay? Okay, the x-intercept is the point on the parabola where y equals 0, so what I'm doing actually is I'm marking, okay, on this graph the zeros of this quadratic equation. Right? I'm marking the zeros of this parabola, which are the zeros that I'm marking the x-intercepts of this parabola, which are the zeros, right? The x values that make my quadratic equation for this parabola equal to 0, okay? How do I come up with those? Well, how far across is our parabola? It's 32, okay? So if I start here, right, I'm in the middle of the top, right? So half of the top, if I go across half the top, I get 16. If this is equal to 16, both of these are equal to 16 inches across, okay? Right, because my total diameter of my parabola is 32. My origin's right in the middle of that, so my distance of the brim of my parabola from the origin is going to be 16. So this point right here is going to be 16, 0. And this point right here is going to be -16, 0. Okay? It's going to be -16, 0. And actually, right now, I have just about everything I need marked that I need. Okay? Let's keep in mind here. Okay? So let's mark these x values. Okay? So what I need to do, right? It's asking for the height of this cylinder. It's asking for this h right here. It's asking for this h. Okay? All right, so what this is doing is, so the x-coordinate, right, let's think about this point right here, okay, the x-coordinate of this point, since I start on the y-axis and I go to the right 8, the x-coordinate of this point is going to be 8, and my y is going to be, I actually don't know what my y is going to be. I don't know what my y is going to be here, okay, this is what we need to find. I don't know what my y is going to be, okay. Because I need the y, because what's going to happen is, all right, this point right here, this is 8, 0, all right, because I'm 8 to the right, right? I'm 8 to the right, and then, but I'm on the x-axis here, okay? The height of my cylinder is going to equal this 0 here, the y value at the top of the cylinder, minus this y right here. I'm actually going to label that y1, so you guys know it's a particular y, minus y1. Okay, so we got to find what y1 is in order to plug that into our h and get the height of my cylinder, okay? So y1, let's look at this point here, okay? This 8, y sub 1, this is a point on my parabola. So what this is here is when I plug my x value, which is equal to 8, into my quadratic equation for this parabola, that's going to spit out the y value here, right? Because that's what quadratic equations do. We plug in x's, they do some squaring, some adding, subtracting, multiplying, dividing, and they spit out a y value, okay? So we got to write the equation, the quadratic equation that models this parabola, okay? So let's think about how we might do that. Okay? So we're going to have y equals, okay, it's a good start, okay? Let's think about what the zeros of my parabola are. The zeros are -16 and +16, okay? So we can write two factors in my parabola. We're going to have x minus 16 times x plus 16, right? Because we know that when we plug in 16 into the equation for my parabola, we're going to get 0 out, right? 16 comma 0. If we plug in negative 16, we're going to get 0 out as well. So negative 16 plus 16 equals 0. Okay, so that takes care of my zeros here, right? But we got to figure out a way to make sure we have this as my y-intercept on my graph, okay? So how do we do that? Okay? So let me think of the best way to explain this, okay? So basically, when we FOIL this out, when we FOIL all this stuff out here, we're going to get something of the form y equals x squared minus something, okay? So what we're going to do is we're going to put a factor here such that when I FOIL all this out, my equation for y is equal to x squared minus 8, okay? Right? Because if we plug in, we want this to end up being the equation. We want this to end up being the expanded equation for our parabola, because the point 0 comma 8 will be on it, because 8 equals 0 squared. 0 comma negative 8 will be on it, because negative 8 equals 0 squared minus 8, okay? Notice how if we just FOIL out this equation as is, we get x squared minus 256. That would make our y-intercept equal to 0 comma negative 256, which is not what we want. We want the y-intercept to be at negative 8, okay? So we got to multiply everything by something, okay? So let's think about this. Okay, let's just call this number, let's call this, I don't know, let's call it like k or something. Let's call it k, okay? So when we factor all this out, expand, we're going to get y equals k times x squared minus 256, okay? Or we're going to get, which gives us kx squared minus 256 over k, okay? We don't need to worry about the k in front of our x squared here. It's not going to do anything to us. But we do need this to equal 8. We need 256 over k to equal 8. Okay, so let's solve for k. We get 256 equals 8k, or 256 over 8 equals k. Let's put that on my calculator. There we go. We get k equals 32. K equals 32. Okay, so we need this k here to be equal here to 32. We need my k to equal 32, right? Oh, you know what I just did? You know what I did here? I made a mistake. I multiplied this out wrong. Sorry about that. It's going to end up being 1 over 32. It's going to end up being 1 over 32 because when I multiply k by negative 256, I get negative 256 times k, not divided by k like I had earlier. Okay, so we need 256k to equal 8. Sorry about that, guys. So k is going to equal 8 over 256, which simplifies to 1 over 32. Okay, so now we know that this k right here, which I just erased, is going to be 1 over 32. So this is going to be the equation of my parabola. So let me get rid of this. Okay, so pause right here before I erase if you need to. That's going to be the equation of my parabola, okay? Right here, okay? So now all we need to do, so let's expand this. We get y equals 1 over 32 times x squared minus 256. We get y equals 1 over 32 times x squared minus 8, okay? Let's highlight that. So we need to go ahead and plug 8 into this equation, and that's going to give me this y sub 1 here. It's going to give me this y coordinate here, okay? Let's do that. We get y equals 1 over 32 times, what is that, 8 squared minus 8. It gives us 64 over 32 minus 8, which gives us 2 minus 8, which equals negative 6. So my y coordinate here is equal to, this point is 8 comma, -6. -6, okay? So my y1 equals -6. Plug that into here, we get h equals 0 minus -6, which equals 6. So h right here, the height of my cylinder here is going to be equal to 6 inches, right? Yeah, the cylinder has to be 6 inches tall. Final answer right here, guys. Thanks for bearing with me. There we go. So pause, rewind. That was a really tough one. Ask Mr. Miller for help if you need to. Ask me for help, okay? So that was number 35. That was number 35 that we just did. Sorry about that. If I confuse you, that's number 35 that we just did, okay? All right, so I'm going to get rid of this. Again, pause, rewind if you need to before I erase. All right, let's move on to 37 here. 37. All right, so we have water stored in a conical tank with a faucet at the bottom. The tank has a depth of 24 inches, and it has a radius of 9 inches, and it's filled to the brim. If the faucet is open to allow the water to flow at a rate of 5 cubic inches per second, what will the depth of the water be after 2 minutes? Okay, what will the depth of the water be? So here's what's going on here. So we start out with a nice little conical tank. I love conical tanks. All right. Okay, what does it say the radius is, the initial radius? Says the initial radius is 9, and the depth, what's the depth? 24, okay? So that's going to be my depth, okay? All right, so if I remember correctly, or if I Google it, right, it's going to be the volume of my cone, of a cone is 1/3 pi r squared h. 1/3 pi r squared h, okay? So that's going to be my volume, okay? So what we need to do, right? So initially this whole thing is filled with water, okay? The whole thing is filled with water. So the total volume of water is just going to be that I start with. So let's say V start is going to equal just the volume of this cone. So 1/3 times pi times 9 squared times 24, okay? Let's put that in my calculator. All right, so I get about 2,035.752, okay? I'll keep 3 decimal places. I'll also store it as a variable in my calculator. I'll show you guys how to store values in your calculator, okay? All right, and then what happens to the volume of my water? What happens to the volume of my water? We lose 5 cubic inches per second for 2 minutes. 5 cubic inches per second for 2 minutes. So in 2 minutes, there are 120 seconds, okay? And we're going to lose, for each of these 120 seconds, we're going to lose 5 cubic inches of water. So we're going to lose, what is that, 600? Let me just put it in my calculator just in case. We're going to lose 600 cubic inches of water. So what's going to happen is my final volume of water is going to be 2,035, or my V start, my starting volume of water, minus 600. Or my V final is going to be about 1,435.752 cubic inches, okay? Cubic inches. All right, so that's my V final. So what they want to know is when my volume is equal to V final, when I have my final volume, so they want to know what my H is. So for when V final equals 1/3 pi R final squared times H final. Oh, there's my timer, guys. Give me 1 sec. Let me finish this problem. Right? They want to know what this is going to be. They want to know what H final is going to be. All right? They want to know what H final is going to be, okay? So we know V final. We got V final right here. We just have to figure out R final. We have to figure out R final, okay? How do I do that? Okay? Well, let's see here. What I think is going on here, okay? So we're going to end, right, their volume of water at the end that we end with, right? It's going to be a little bit of a smaller cone, right? It's going to be a smaller cone. It's going to have a radius of R final and a height of H final. Okay, that's all right. So that's going to be my ending cone, okay? What's happening here, notice this little blue triangle and this green triangle here. These are going to be similar triangles. Okay? So that means is, okay, if we remember geometry, okay, so my right triangle here, the 24, 9, okay, that's going to be similar to R final radius, and H final heights. These are going to be similar, okay? So what's happening is R over H is going to equal 9 over 24, okay? It's going to equal 9 over 24, or R is going to equal 9 over 9/24 H. Okay, so this is important. So let's highlight this. Okay. What we can do then is we can plug this back into my equation for R final, and we'll have 1,435 equals 1/3 times pi times 9/24 H squared times H. So we'll have one equation and one unknown that we can solve for. Okay, so let's do that real quick. So we're going to have V final, which is, I'm just going to leave that as V final for now, okay? And I'll plug in all my values at the end. So V final equals 1/3 times pi times R, which is 9 over 24 H squared times H. Now I'm going to solve this equation for H, okay? So I'm going to multiply by 3 on both sides. Okay, get rid of my 1/3. Okay, I'm going to divide by pi on both sides, get rid of my pi. All right, and then so I'll have 3 times my V final over pi equals, what's 9/24 squared? It's going to be, my calculator. It's going to be 9 over 64. All right, this is going to be 9 over 64 H cubed. All right, so let's multiply by 64 over 9 on both sides. All right, this simplifies to 64 V final over 3 pi. That equals H cubed. Okay, then to get rid of my 3 here in the exponent, I'm just going to raise both sides to the 1/3. So I get H equals 64 times V final all over 3 pi to the 1/3, okay? And then I can plug in my value for V final from up here. All right, I can plug that in. That gives me H equals 64 times, times 1,435.752 all over 3 pi, all that raised to the 1/3. Okay, all that raised to the 1/3. Let's do that on my calculator, okay? So I'll just take a picture of this so I can remember it. Okay, so let's go over to calculate 84. Okay, so here's my graphing calculator. We're gonna do, let's do 64 times 1,435.752. All right, right parenthesis divided by 3 pi. All right, so we just do our multiplication in the top and divide by 3 pi. Okay, remember those parentheses, okay, because the order matters. You hit enter, and then hit the caret symbol, left parenthesis 1 divided by 3, so raising all that to the 1/3. We get 21.363 inches. So 21.363 inches. Sorry, guys, I thought I'd be able to get all those problems done in 25 minutes, but I guess not. So let's go ahead, guys. Let's go ahead. Let's hold off on the homework for Monday, okay? Let's just go ahead, or whenever I see you next. Hold off on the homework for whenever I see you next. Okay, well, I'll give you a video lecture finishing these 3 problems next time, and then I'll assign the 1.7 homework for 2 classes from now. 2 classes from now, okay? And hopefully we can start the Unit 2 notes next week, okay? So you'll finish a short video on this, and then we can start the Unit 2 notes. I'll give a video for that as well. Okay, so take care, guys. Ask Mr. Miller if you have questions. Pause, rewind, ask Mrs. Ford and Miss White for help too, okay? Take care, guys. Bye.